Today we will learn histogram of uniform width. In a school, a computer teacher organized a competition to understand the students' typing speed, in which the students were given 5 minutes and asked to type a text of English. Following information was collected about how many words students type in a given time. Due to large number of observations, they thought it would be appropriate to organize them into a grouped frequency distribution table as follows. Can you tell what kind of distribution it is? Think. Absolutely right. Since the class intervals are continuous, it is a continuous frequency distribution. If we represent these figures in a pictorial form, we can get information more easily. Let's represent these figures in a pictorial form. Can you tell if a bar graph would be appropriate to represent these data or a histogram? Think. Let me tell you. Histograms are an appropriate means to represent continuous class intervals. Therefore, we will represent these figures as histograms. First, draw the x-axis and y-axis on graph. On the x-axis, we will take the number of words typed in 5 minutes and the number of students on the y-axis. Here, class width, that is, class width of all class interval is same, which is 20 words. Therefore, we will take the scale 1 unit is equal to 20 words on the x-axis. Class intervals begin at 60 and end at 180. Since the first square interval is starting from 60 here, we do not have to show numbers from 0 to 60 on the x-axis. To show that we are not taking the numbers from 0 to 60, we will draw a king symbol on the x-axis in this way. Thus, keeping in mind the scale on the x-axis, we will show numbers from 60 to 180. To show the number of students, we also have to take the appropriate scale on the y-axis. Here, a suitable scale would be 1 so that we can properly represent the smallest number 1 and the largest number 30. We can take this scale for the y-axis by 1 unit is equal to 5 students. Since the numbers 30, 15 and 10 are multiples of 5, it would be easy to represent them. Similarly, we can do 1 unit is equal to 5 students. Taking this scale and divide it into 5 equal parts of the unit, which will help us to represent numbers such as 1, 4 and 22. In this way, with the help of this scale, 1 unit is equal to 5 students, we will properly represent other numbers along with smallest and largest numbers. By choosing the scale, we will show the numbers on the y-axis. Now, we will represent the frequencies of class interval with rectangles. The frequency of class intervals 60 to 80 is 30. So, we will draw a rectangle for this class interval in such a way that the length will represent 30 students. Similarly, we will also draw rectangles for class intervals 80 to 100. Similarly, we will draw rectangles for all class intervals. The area of rectangle to be drawn for a class interval in a histogram is proportional to the frequency of that class interval. But here we have kept the frequency proportional to the length. Is it fair? Think. Let me tell you. We know that the area of a rectangle is length multiplied by width. Here, width of each class interval is the same. So, the width of rectangles to be drawn for them will also be same. If the width of rectangle is kept the same, then its area is proportional to its length. In this way, width of each class interval is the same. Then, the length of the rectangle can be taken in proportion to the frequency of the square intervals. This will also make the area of the rectangle proportional to the frequency of that class interval. In this way, we will get a histogram. Here, the data is classified as continuous frequency distribution. Since the histogram is used to represent a continuous frequency distribution, it does not contain distances or spaces between rectangles. As you can see in this histogram, there is no spaces between the rectangles. Various information can be obtained by looking at this histogram. The maximum number of children who can type 60 to 80 words in 5 minutes. We can see that only one student types 160 to 180 words in 5 minutes. When the class intervals have the same width, we get the histogram of uniform width. If the width of the class interval is not the same, then we get an histogram of varying width, which we will discuss in the next video. So today we learned about histogram of uniform width. In the next video, we will discuss about histogram of varying width. Today we will learn about histogram of varying width. In the previous video, we learned about the histogram of uniform width, in which we represent the number of words the students typed in 5 minutes as histogram of same width. Suppose a student classified these data in this way. Is the table the same as the one made in the previous video? No. Here we see that the class width of first class interval is 100 minus 60 is equal to 40. The class width of the second class interval is 120 minus 100 is equal to 20. And the class width of the third class interval is 180 minus 120 is equal to 60. Thus, the class width of the class intervals are different in this frequency distribution table. In order to represent these figures, the student drew the histogram in such a way that the length of rectangles to be drawn for class intervals was proportional to frequency. Did he draw the correct histogram? Think. No, this is an incorrect histogram. Let's understand the reason for this. We know that the area of a rectangle in a histogram is proportional to the frequency it represents. According to this statement, the area of each rectangle here should be proportional to the frequency. Since the frequencies of the class interval 100 to 120 and the class interval 120 to 180 are the same, the area of rectangles representing them should also be same, but the area of both appears different here. We can also understand it mathematically. Here we see that the rectangle representing the frequency 15 of the class interval 100 to 120 is 1.5 units in length and 1 unit of width. Thus, the area of this rectangle is length multiplied by width is equal to 1.5 square units. Similarly, the rectangle denoting the frequency 15 of the class interval 120 to 180 is 1.5 units in length and 3 units of width. Thus, the area of this rectangle is equal to 4.5 square unit. The ratio of the area of these rectangles is 1/3, but the ratio of frequency of both these class intervals is 1:1. Since the ratio of areas of rectangle is not proportional to their corresponding frequencies, the areas of rectangles are not proportional to the frequencies here. That is, these histograms show the wrong frequency of the corresponding class intervals. So this histogram is wrong. In the histogram, the area of rectangles must be proportional to frequency. The width of the rectangles depends on the class width of the class. The class widths here are different. Therefore, the width of the rectangles will also vary. If we want the area of rectangles to be proportional to the frequency, we must change the width or length of the rectangles. But the class width of each class interval is fixed. So, we cannot change the width of rectangles. So, we have to change the length of rectangles. Can you tell us how we will make this change? Think. Let us tell. For this, we will find the lowest class width of class intervals. Here, the class intervals are 100 to 120, class width 20 is the minimum class width. Now, we will multiply the result by the minimum class width by dividing the frequency of that class interval by the width of that class interval to find the length of rectangle of each class interval. For example, here the length of rectangle of interval 60 to 100 can be obtained as follows. Similarly, the lengths of the rectangle of other class intervals can be obtained in this way. Now, we will draw rectangles with a suitable scale for each class interval. Here, we have taken 1 unit is equal to 20 words on the x-axis and 1 unit is equal to 5 student scale on y-axis, from which we have obtained the histogram in this way. Now, you stop the video and find out whether the area of rectangle in this histogram is proportional to the frequencies or not. Try it. You must know that now the area of rectangles is proportional to frequencies. Hopefully, you can now draw a histogram of varying width for a graded frequency distribution that has different widths of class interval. Today we have learned histograms of varying width. In the next video, we will see some examples of histogram. Today we will see some interesting examples related to histogram. Vinita had to know how many people are literate in her village. To find out, Vinita conducted a survey in the village. The information obtained from the survey was presented by Vinita in the frequency distribution table shown below. Can you represent this information as a histogram? In the given table, the width of all class intervals is not the same. Here, we have to make suitable changes in the lengths so that the area of rectangles is proportional to the frequency of the class interval. For this, we will first find the width of each class interval and choose the lowest class width. That is, here we will choose 10. Now, we will change the lengths of the rectangles in such a way that class width is proportional to 10. For this, we will divide the frequency of each class interval by its class width and multiply it by the minimum class width of 10. Thus, the length of the rectangle for the age group 10 to 20 will be 360 divided by 10 multiplied by 10 is equal to 360. Since the class width of the class interval 10 to 20 is already 10, therefore, there was no change in the length of its rectangle. Similarly, we will find the length of rectangles for all age group. Now, we will show the age groups on the x-axis and the number of literate people on the y-axis. For this, we will take 1 unit is equal to 10 years on the x-axis and 1 unit is equal to 40 persons on the y-axis. Since we are starting with 10 on the x-axis, we will thus make a kink symbol indicating that we are not showing numbers from 0 to 10. Now, we will draw the rectangle by keeping the width of the rectangle 10 and the length of the rectangle 360 for the age group 10 to 20. Similarly, we will draw the rectangle by taking suitable width and length for all age groups. In this way, we will complete the histogram. Thus, we have represented the information given as a histogram. Next example, Shruti is a reporter. To publish the news in the newspaper, Shruti studied the change in the price of 14.2 kg of liquefied petroleum gas, that is LPG, from the year 2006 to 2012. The information received was thus represented as a histogram and printed in the newspaper. Now, read this histogram and answer the questions below. The histogram shown here shows the change in the price of LPG over different years, in which the x-axis represent years and y-axis represent price of LPG per 14.2 kg. Here, the width of each class interval is the same, that is 1 year, and the scale of y-axis in 1 unit is equal to 100 rupees. Look at the histogram and find out for how many years the price of liquefied petroleum gas, that is LPG, is less than 500 rupees. Here we see that price of liquefied petroleum gas is less than 500 rupees in the year intervals 2006 to 2007, 2007 to 2008, 2008 to 2009. Here, the width of each class is 1 year. Therefore, we can say that the price of LPG has been less than 500 rupees for 3 years. Can you tell what is the percentage increase in LPG price in the year 2008 as compared to year 2007? Here, the price of LPG in 2008 is 420 and in 2007 the price of LPG is 340. In this way, the price of LPG increased from rupees 420 minus rupees 340 is equal to rupees 80 from the year 2007 to 2008. This increase has been made at 340 rupees, so we will consider 340 as the base. In this way, the price of LPG has increased by 23.53%. Look at the histogram and find out how many years price of LPG ranged from 500 rupees to 800 rupees. In the year 2009-2010, in the year 2010-2011, class intervals, the price of LPG is between 500 and 800. So, we can say that in 2 years, the price of LPG ranged from 500 rupees to 800 rupees. Now, pause the video and try to make a histogram with this information. Today, we have seen some interesting examples related to histogram. In the next video, we will see some misconceptions related to them. Today we will see misconceptions related to histogram. Some students think that a bar graph and a histogram are the same. If they are asked to represent some information in a histogram, they make a bar graph. It is a misconception to think that bar graphs and histograms are same. Let's understand this. The data shown here in this table show the number of readers of different age groups visiting the library of Rahul's village in March. Rohan represented this information as a bar graph and Sohan represented this information as a histogram. Can you find the difference between two by looking at them? Think. Let me tell you, the same figures are represented differently in bar graphs and histogram. Both types of representations are correct in their respective places, but differences can be seen between the two. For example, in a bar graph, the length of bars is proportional to the frequency of observation. That is, the frequency of observations is represented as the length of bars, where the area of rectangles in the histogram is proportional to the frequency of the class intervals. That is, the frequencies are represented as the area of rectangle and not the length of the rectangle. Similarly, the bars in the bar graphs are of the same width, while it is not necessary in the histogram. If the class intervals are of the same width, then the rectangles are the same width, but if the class intervals are not of the same width, then the rectangles are also not of the same width. Histograms are created for continuous group frequency distribution, so there is no gap between rectangles. Bar graphs are drawn to compare different categories, while histograms are drawn to understand the distribution of data. For example, in this bar graph, all three age groups are taken as one category. Readers of different age groups can be compared. Like here, most readers are between 20 to 40 years of age. If we look in the histogram, we find the distribution of the number of readers in the age of 10 to 40. Today we have seen the misconception related to histogram.